Good evening, everyone. This is the test related to topic moment, momentum, and pressure. In this session, I'll discuss the questions. So, in the first question, an athlete is there of mass 70 kilograms. So, if mass of athlete is 70 kilogram, his weight will be 700 Newton. And he's performing press ups with a load on his back, and the weight of this load is 6 kilograms. So, if it is 6 kilogram, it means it is 60 newtons. And he's pushing with the hand. There's an upward force that we have to calculate. So this point is a pivot around which this body can rotate. So 760 both are causing a moment in opposite to direction of the clock or anti-clockwise, and F is causing a clockwise moment. Because whenever we are solving a question related to moment, we assume that the object is balanced. So the total anti-clockwise moment is equals to total clockwise moment. The anti-clockwise moment, that is 700 multiplied by distance from the pivot. So this distance, the weight, it is 0.9, so 700 into 0.9 plus the 60 Newton is causing a moment. And what is the distance from the center of the mass? So it is 0.9 plus 0.3, so it is 1.2 equal to the clockwise moment. So it is F multiplied by distance from the pivot. So it is 1.3. So when we simplify 700 into 0.9 plus 60 into 1.2 divided by 1.3, this will give us the force, which will come out as 540 newtons. So C will be the right answer. Then an air pistol fires a pellet forward. What is the motion of the air pistol? So if example, this is an air pistol and it fires the pellet. If the pellet is moving forward, which direction the pistol will move? It will move backward. And because they have different, they will have the same momentum. Mass of the bullet is small, so its velocity will be higher. Mass of the pistol is more, so its velocity will be smaller. But the product of the mass and velocity will be same. That's why for question number 2, B will be the right answer. So the pistol move backward, but the speed at which the pistol move will be less than the speed of the pellet. Then question 3, a skier is standing still on a flat area as shown here in the figure. His weight, the weight is 550, so pressure is force divided by area. So force is 550 and the area, that is 0.015. So 550 divided by 0.015, so this will give us 36,666 Newton per meter square. So this is closer to which value? 36,666. That is about 37,000 Newton per meter square. Then a tall cylinder is there which is partially filled with two liquids which do not mix, so they have different densities. So the liquid which is up will have low density, and the liquid which is down, it will have a high density because the denser liquids sink. So when we move from P to Q, because in liquid P, as we know, pressure increases with the depth. As we go deeper inside, the pressure will increase. But because the density of the liquid, the first liquid is smaller as compared to density of the second liquid. So here the pressure will change, the pressure will increase, but a small increase in pressure. Whereas when a denser liquid, when we move in the denser liquid, as the depth, overall depth is increasing, so pressure will increase, as well as the density is higher, the pressure will also increase. So that's why the increase in a pressure will be greater in the denser liquid as compared to increase in pressure in the rarer liquid or low density liquid. That's why B is the right answer. Then question 5, an object is pivoted. A student try to find the length of a string. She pulls by a force F. So we want to calculate a moment. So whenever we want to calculate a moment, moment is force multiplied by perpendicular distance. So what is the perpendicular distance between the force and the pivot? If this point is a pivot, here is a force, so the 90-degree distance is S. So we want to calculate a moment, so it will be F into S. So we always take a perpendicular distance between the force and the pivot. Then the kinetic energy does not changes. It does not depend on the direction. So if a gas molecule is moving, it rebound with the same speed. So here the momentum is example mv. When it rebound, the momentum will be minus mv. So is there a change in momentum? Yes, there is a change in momentum because if direction changes or the magnitude change. But what about kinetic energy? As we know, kinetic energy is half mv square. It does not depend on the direction. So we just substitute the values. So it will be same. So kinetic energy stays the same, but because there is a change in direction, so the momentum changes. The diagram shows a manometer. So first thing, as you can see, the level, the side where the gas is connected, that is down, and the side where atmosphere is, it is open to atmosphere, that is up. It means the gas pressure is more. And when gas pressure is more, what we can say? We can say the gas pressure is above atmosphere. And how much the gas pressure is above atmosphere, the difference in the level. So this is 300 and this is 100. So the difference in the level is 200. So as the difference in the level is 200, it means the gas pressure is 200 millimeter because this scale is given in millimeter. So it is 200 millimeter above the atmospheric pressure because the term above means higher and below means lower. So gas pressure is higher than atmosphere. That's why we say above. And how much it is above, that is the difference in the level. So the first level is 100 millimeter, the second level is 300. Difference in the level is 200 millimeter. The diagram shows the dimension 6, 8 and 4. The box rests on the flat horizontal surface. Which face must the box rest in order to exert the least pressure? So to exert the least pressure, because pressure is forced by area, so the area should be more so that the pressure will be less. What is the area of face X, face Y basically? So this is 4 and this one is 6. So 4 multiplied by 6, that is 24. What about the surface area of X? So this is 6 and 8. So 6 multiplied by 8, that is equals to 48. And what about Z? This is 8 and this one is 4. So 8 multiplied by 4, that is equals to 32. So which is having the largest area? X is having the largest area. So it will exert the least pressure when it is facing this X. A mass of a ball is 2 kilogram. It approaches with a speed of 3 and it rebound. So because if one of the velocity we take negative, the other one should be positive. Velocity is a vector quantity, or if one of the momentum, you can calculate either a momentum or the velocity. Like I can calculate the mass is 2. Here also mass is 2. So what is the momentum? 3 multiplied by 2, 6 kilogram meter per second. What is the momentum? 2 multiplied by 1, 2 kilogram meter per second. So momentum is a vector quantity. If one you take positive or negative, the other one should be positive. So what will be the impulse? Impulse is a change in momentum. So it is final momentum minus the initial momentum. The final momentum is 2 minus and the initial momentum is minus 6. So when we simplify it, minus minus is plus. So 2 plus 6, and that is equals to 8 Newton second. So D is the right answer. In question 10, a book is there having a mass of 400 gram. The surface of a book is in contact, zero point 0.1 into zero point 0.2. The gravitational field strength is, what is the pressure? So to calculate a pressure, pressure is force divided by area. But mass is not the force, weight is the force. But before converting into weight using a formula W is equals to mg, the mass should always be in kilogram. So first we divide by 1000. So 400 divided by 1000, it is 0.4 kg. And then 0.4 kg multiplied by gravity, that will give us the weight, which is equals to 4 Newton. So weight is how much? It is 4 Newton. And what about area? Zero point 0.1 into zero point 0.2, that is 0.02. So 4 divided by 0.02, that is equals to 200 Newton per meter square. So D will be the right answer. So whenever a question is there, you want the weight. So mass should always be in kilogram, and then you use the formula that weight is mass multiplied by gravity. Don't use the mass in gram in this formula because the SI unit of mass is kilogram. The diagram shows a mercury barometer at which point there is a greater pressure than atmosphere. Because what happened when we compare point D, because what happened at point D, there is a pressure of the liquid and there is a pressure due to the atmosphere as well. So which point will have the highest pressure? That is D, because that is under the liquid, and when we go deep inside the liquid, the pressure will increase. So D is the right answer, that the pressure is greater at point D as it is deep inside the liquid. Question 12. The diagram shows a solid block resting on the bench. Dimension are there. Which surface should rest to produce the smallest pressure? So if we want to reduce the pressure, means we have to increase the area. So which is having a large area? This is 80 and this one is 40. So 80 multiplied by 40. 8 multiplied by 4, that is 32. So 3200. Then this will be 20 multiplied by 40. This surface. So 2 multiplied by 4 is 8. So this will be 800. And what about this side? This is 80 and this one is 20. So 80 multiplied by 20. So it will be 1600. So we have these sides which is having the least area will exert the most, which is having the least area will exert the most pressure, and which is having the largest area will exert the least pressure. So P is having 3200. So it will exert the least pressure on the surface. The pressure due to the liquid is immersed. The pressure is 45,000 Pascal. Density is, what is the depth? So we have the formula pressure is equals to density, gravity and depth. So pressure is 45,000, sorry, 4,500. The density is 900, gravity is 10 into h. So it will be 4,500, 9,000 into h. When we simplify, 4,500 divided by 9,000 is h. So when we simplify, it will come out as 0.5. But what is the unit? This will always, the height should always be in meter, because we are using the SI unit for density, kilogram per meter cube. The gravity is meter per second square. So the height will come out in meter. But all the options are in centimeters. So we have to convert this 0.5 meter into centimeter. So to convert meter into centimeter, we'll multiply by 100. So it will come out as 50 centimeters. So C will be the right answer. A barometer read 780 millimeter. Always, whenever you are using a pressure exerted, what is the pressure of the atmosphere? Basically, the pressure exerted by the liquid is equals to pressure of the atmosphere. So it is equals to density, gravity and depth. The density is 1.36 into 10 to the power 4. Gravity of the earth is 10. What about the depth? It is 760 millimeters. So we divide by 1000. So it will be 0.78 meter. So it will be 0.78. Whenever you are substituting the depth here in this formula, it should always be in meter. So for question 14, when we substitute the values, it will come out 1.1 into 10 to the power 5 Newton per meter square. Then an object with a mass 0.5 and moving at 0.2, which object has a momentum, identical momentum, because momentum changes with the direction, so they should have the same direction as well. So only object which is moving towards the right hand side is C. So without calculation, I can say first we'll check the direction and then we'll calculate as well, because zero point 0.4 multiplied by zero point 0.1, it is 0.04, and this is also 0.04. So both have the same magnitude and both have the same direction. That's why they have the same momentum. Then the diagram shows a mercury barometer. Which height is used to measure the atmospheric pressure? So the height which we use, we read the level of the liquid in a container to a level of the liquid in the tube. That is the height which we read in a mercury barometer. So that matches with option C. The structure question shows an athlete crossing a finish line. She crosses a finish line. Her speed is 10 and she slowed down to 4 meter per second. The mass of athlete is 71. Calculate the impulse. Impulse is a change in momentum. Impulse is having two formula. Impulse is mv minus mu, or impulse is force multiplied by time. But we don't know the force. So we are using the first formula. The impulse is mv. So 71 into final speed is 4 minus mu. So 71 into initial speed is 10. So when we simplify, it will give us the negative answer. Negative answer also shows that the force is upward, the impulse is negative, or the object is slowing down. So it is minus 430. Even you just need a magnitude. If you write 430 Newton second or kilogram meter per second, that is right. Then define impulse. Impulse is the product of force and time. It takes 1.2 seconds to change the speed. We need average force. So impulse is force multiplied by time. So force is impulse divided by time. Impulse we already calculated, which was 430, and the time is 1.2. So 430 divided by 1.2, so it is about 355 Newton. Then calculate the force required to give a mass 70 acceleration. So we have the formula which relate force mass and acceleration. F is equals to ma. So mass is 71 and acceleration is 6.4. So 71 multiplied by 6.4 will get about 454 Newton. Then use the formula to get the mass and find the dense weight by using a formula. W is equals to mg. So first, using a formula of a density, we have the density and we have area, but thickness is in centimeter, area in meter square. Both should be in the same unit, because if density is kilogram per meter cube, area should be in meter square and length should be in meter. So we have to convert 2 centimeter into meter, so 0.02 meter. Then we'll use the formula. Density is mass over volume. So density is 2.6 into 10 to the power 3. Mass we don't know, and the volume is how much. Volume is area multiplied by height, or area multiplied by length or thickness. So 0.15 multiplied by 0.02. This whole is divided. Other side it will be multiplied. So this will give us the mass of the object when we multiply these two. So 0.15 into 0.02 multiplied by 2.6 into 10 to the power 3. So this will give us 7.5, 7.8 kilogram. But we need the weight of an object. So if mass is 7.8 kilogram, the weight will be mass multiplied by gravity. So it will be 7.8 times 10. So it is equals to 780 newtons. Then a piece of glass as shown as vertical viewing window. Aquarium is there. The vertical aquarium is there, which is having, like, this is the aquarium, the wall of the aquarium made up of this glass, and aquarium is filled with water. So the atmospheric pressure from outside, this is the pressure from outside, which is how much? It is 1 into 10 power 5 Pascal. And what is the pressure from inside? It is 1.3 into 10 power 5 Pascal. Calculate the resultant force. So as it is obvious that from the resultant force should be outward. Why? Because from pressure from inside is more and pressure from outside is less. So it means the resultant force should be in this direction, because 1.3 exponent 5 pressure is more than 1.1 into 10 power 5. So the resultant pressure will be towards outside, and resultant force should also be outwards. Then how to get that force? First, we know what is the pressure. It experienced 1.3 from 1.3 is outside and 1 exponent is inside. So the difference in the pressure, 1.3 into 10 power 5 minus 1 into 10 power 5. So it will be 0.3 into 10 power 5 Pascal. That is the resultant pressure. And from resultant pressure, we can work out the force. Pressure is force divided by area. So force is pressure multiplied by area. So resultant force will be resultant pressure, which was 0.3 into 10 power 5 multiplied by area, that already in the previous part it is given. The surface area is 0.15, so it will be 0.15 meter square is there, so we multiply 0.15 and this will give us how much force this will experience outward. So it will be 4.5 into 10 power 3, or you can also solve in another way, like you calculate the force on it from inward and force from outward, and then take a difference of the force to get the resultant force. So both ways it can be done. You calculate a difference in the pressure, and that difference in the pressure will give you the resultant pressure, because they are in opposite direction. And then using a formula, you will get. Or the second method which I mentioned, you have the area 0.15, so I'll calculate a force here. So the force here will be 1 into 10 power 5 multiplied by 0.15. So 100,000 Pascal times 0.15, so it is 15,000 Newton force. And the force from this side, it is 1.3 into 10 power 5 multiplied by 0.15. So 130, 130,000 multiplied by 0.15, this will give us, so this will give us 19,500 Newton. And when we take a difference of the two, so 19,500 minus 15,000, so that is equals to 4,500 Newton, which is 4.5 into 10 power 3. So both ways, either first calculate a difference in the pressure and then calculate the air using a area, find the force, or first calculate force on each side and calculate the difference in the force. Figure 1.1 shows a vacuum connected The height is 12 meter. Calculate the density. So how to calculate the density? The formula is pressure is equals to density, gravity and depth. The pressure is 9.6 into 10 to the power 4. Density we don't know. Gravity is 10 and the depth is 12. So this factor is multiplied. Other side will be divided. So 9.6 into 10 to the power 4 divided by 10 divided by 12. This is 12. So this will give us the density of the liquid which is used, that is 800 kilogram per meter cube. Whenever you're using the formula, keep in mind, like sometimes they change the question, they give you in centimeter. So always convert the height into meter before using in the formula. State what is meant by moment of the force. Moment of the force, which refers to a turning effect. When force applied to move the object around a fixed point, we call that as moment of the force. So force cause rotation around the fixed point. So when force causes a rotation around the fixed point, that force is known as, or this effect is known as turning effect. Calculate a moment about A. About A means A is a pivot. When mass is 14,000, if mass is 14,000, weight is the force, mass is not the force, so how much is the weight? It will be 140,000. Why? Because mass we convert into weight by multiplying with gravity. So we want to calculate a moment, so it will be 140,000 times 20. So 14 multiplied by 2, that is 28. Or we can convert 1, 2, 3, 4, 5, 6. So we can say 2.8 into 10 to the power 6 Newton meter. So whenever we are calculating a moment, the force multiplied by perpendicular distance from the point of rotation, or we can also say pivot. Speed is a scalar, velocity is a vector. What is the difference between scalar and vector? So scalar and vector, scalars have magnitude and unit only. But what vectors have? Vectors have magnitude, unit, and the most important thing is a direction. Then scalar quantity, like example, you can mention time is a scalar quantity, and vector quantity like force or weight is a vector quantity. Figure shows a device that uses a liquid pressure to lift the heavy block. The boxes are lifted by pumping oil into a cylinder. The force the force upward on the piston is due to the oil. So the oil is exerting an upward force. Example, this green arrow is representing the force of the oil. And the downward force is there due to the air. So air is also exerting a downward force. So red arrow example representing the force of the air. So because two forces are acting in opposite direction and this is lifted up, so it means the resultant force will be equal to force of air minus force of oil. That will give us the resultant force. But we in the question we have to calculate the pressure of the oil. So how to calculate the pressure of the oil? In the question they mentioned the combined force is 8,800. So resultant force is how much? This force is how much? It is 8,800 Newton. The surface area is given and atmospheric pressure is given. So first we'll find the force from the atmosphere, because pressure is force acting on unit area. So pressure of the atmosphere is given. The atmosphere exerting a pressure of 1 into 10 power 5 Pascal. That's a normal atmospheric pressure. So this is 1 into 10 power 5. and the area is 0.016 or 0.016. So 100,000 Pascal times 0.016. So this, when we multiply these two, this will give us 1600 Newton. That's the force of the air. So the force exerted by the air is 1600 Newton. Force of the oil we don't know. So first, because the resultant two forces are in opposite directions, so resultant force should be the difference of the two. So resultant force is 8800, force of air is 1600, force of oil we don't know. When we simplify, force of oil will move other side, or because resultant force, I can also write in terms of force of oil minus force of, because it is being lifted up, so means the force of the oil is more. So I should write the greater force first. So force of the oil is more than the force of the air. So force of oil minus force of air. So force of the oil we don't know, and force of the air is how much? We calculated it is 1600. So this minus, it will move other side plus. So total force plus 1600 will be the force of the oil. So 8800 plus 1600, this will give us 10,400. 10,400 Newton is the force of the oil, but we need the pressure. So pressure is force divided by area. So force is 10,400 divided by area is 0.016. So it will be, the pressure exerted by the oil is 650,000 Pascal. So this is how we work out the pressure exerted by the oil, because the air is exerting a downward force, oil is exerting upward. So resultant force is equals to force of oil minus force of air. So this was the last question related to test moment, momentum and pressure.